Hello, my name is Wayne Busek, and I'm an IT specialist with IBM. Today we will be discussing making user application data available to analytics tools using the IBM Common Data Provider. Our topics will include how data from ZOS gets streamed using the Common Data Provider. We'll take a look at the features of the product at a very high level, talk for a moment about the importance of data curation, and then look at the specifics involved in ingesting CICS event data. Analytics are all the rage these days, and analytics in near real time is a phrase that you hear frequently. Near real time in the context of Common Data Provider means almost instantaneously after the data becomes available. Common Data Provider is intended to be the single source of Z data in your environment. In addition to the supported out-of-the-box data types, the solution is an extensible solution, and that's what we'll be discussing today along the lines of making CICS event data available as a user SMF record and other types. The product has advanced data filtering capabilities that allow you to control the amount of data that is streamed and ultimately ingested in your analytics solution. We provide insights in the form of dashboards and quick searches to turn that data into useful information. Last but not least, the product is 100% zip eligible in terms of runtime components, which helps to control the total cost of ownership. On the left-hand side of the screen, you see the data types that can be streamed using CDP. SMF data, log data, and even user data streams can be developed using an API. In the bottom left-hand side of the screen, you see some special cases of interest where some products actually take advantage of Common Data Provider to stream data, specifically the IBM Z Performance Capacity Analytics product, IMS Connect extensions, and NetView Netlog are examples of data types that CDP can harvest and then make available to the analytics platform of your choice. On the right-hand side of the screen, you see those analytics platforms listed in terms of Splunk, Elasticsearch, the IBM Z Data Analytics Platform, Logstash to enable any analytics platform to avail itself of CDP's data as long as that analytics tool has a Logstash output plugin. Kafka is another area that we can stream data. CDP is configured using a web configuration tool. That tool is used to generate a policy where the policy contains data streams indicating which data types will be collected. The policy configuration tool runs in ZOSMF or can run standalone in a Liberty application server. On the right-hand side of the screen, you see a depiction of that policy configuration tool. In blue, you see the data streams that have been identified. In this case, ZOS syslog SMF 108 subtype 1s, NetView Netlogs, and CICS message user. Moving to the right, in purple, you see transforms. And transforms are there to format the data being sent in a fashion that will be acceptable to the various subscriber types. Transforms also include filtering capability using regex, where include and exclude filters can be defined. Subscribers in green are on the far side of the screen, in this case Splunk, Elasticsearch, Splunk number 2. What we really want to point out about subscribers is that you can mix the bag in terms of type. You can have as many subscribers as you so choose, and you can even echo messaged content out to multiple subscribers at the same time. The data streams are configured using a point-and-click GUI. On the upper left-hand side of the screen, you see the Common Data Provider data streams listed: dcollect, IMS data, ZOS, batch, security, network, web servers, all the way down to CICS and below. And then on the bottom of the screen, you see there is also another category of data streams, the IBM Z operational log and data analytics data streams. Note here that they look very similar in terms of content to what you see for Common Data Provider above. We'll get into that later, but for now, just note the difference. Moving to the right, we've expanded the CICS transaction server category so that we can now see CICS log data, CICS CMF data, CICS statistics data, and CICS other data as categories under CICS transaction server, which Common Data Provider can collect data on. Finally, on the right-hand side of the screen, we've opened up the twisty next to CICS CMF data to take a look at those 110 records. At this point, most of what you see there relates to a CICS 110 record that you're acquainted with. The CICS 110 KPI record is a special case curated record which Common Data Provider delivers. We'll talk more about that one in 2 screens. Dashboards and searches are delivered out of the box for z/OS, WebSphere, DB2, CICS, IMS, MQ, and networking. On the bottom left side of the screen, you see the CICS transaction server for z/OS transactions dashboard on Splunk, as well as the CICS transaction server for z/OS regions dashboard on the Z Data Analytics platform. Those dashboards are all built using the Z operational log data analytics data streams. On the right-hand side, you see there are saved searches for all of the categories listed below. We've opened up the CICS transaction server for z/OS saved searches. All of these saved searches are queries against syslog traffic that has been generated by CICS and can be used during a real-time firefight to understand the behavior of your CICS system. So that takes us to curated data. And curated data really has 2 value propositions, the first being resource optimization. If you consider the CICS 110 records, those records are both tall and fat, so to speak, in that those records are about 16K bytes in width, but most sites produce millions, tens of millions, even up to 1 billion records daily. So it becomes a real challenge in terms of storage management in trying to make the data found in the CICS transaction records accessible. What we've done with Common Data Provider, and most notably in that KPI record that we talked about just a couple of minutes ago, have cherry-picked the important fields in the record, the most used fields, such that we've taken an average raw 110 record of 16K bytes and cut that down to just under 600 bytes. With a 95% reduction in total size, it's now possible to stream those records into your analytics tool. Another way we've addressed this is by making summary records. Rather than having one transaction equal one record, we've summarized on 1-minute intervals by transaction. And if you have a transaction that runs 100,000 times in a minute, you can cut down your total number of records which you are ingesting into your analytics tool down to a single record that represents the behavior of that transaction. The dashboards which we have for CICS, DB2, and other are built on the notion of summary records. Data enrichment is another aspect of data curation. If you've ever looked at SMF records, you're probably well aware that the values that you might be interested in, such as CPU utilization, are not provided directly in some of the records. You need to create a derived quantity by doing math on multiple fields to arrive at the value you're interested in. So Common Data Provider and IZOA provide that through data curation. Lastly, user records, which is what we're here to talk about today, employs the same mechanism in terms of curation, where in this case, we'll read in a user record and take it apart and format it appropriately. Here's a look at the architecture of Common Data Provider and the components involved to perform all the capabilities that we just discussed. CDP has the following types of components: a configuration tool, data gatherers, a data streamer, and ultimately the subscribers or data targets. On the left-hand side of the screen, you see the potential data sources: SMF data, log data, or user application data. All of those data types are managed and collected with a data gatherer. The system data engine, the top data gatherer listed, is responsible for the collection of all SMF data. Below that, the log forwarder is responsible for the collection of all other data types. At the bottom, you see that user application is available using an API to create your own data streams. Once the data is collected by a data gatherer, that data flows to the right into the data streamer. The data streamer address space then formats and delivers via a network connection the stream data into the analytics platform of your choice. On the right-hand side, we see the analytics platforms listed: the Z Data Analytics Platform, Logstash, Humio, Kafka, Elasticstack, and Splunk are all supported by Common Data Provider. And that gets us to CICS Event Processing adapters and how will they work with CDP. On the left-hand side, you see a list of the supported data stream types. So syslog, joblog, DD statements can be read. VSAM ESDSs can be read directly, as well as files in the USS file system. The API, which we mentioned, and then user SMF records. If we look on the right-hand side of the screen, we see that CICS Event Processing adapter type list doesn't really map to what we see for Common Data Provider. Event processing adapters for MQ, HTTP, and CICS temp storage would require an extra step external to this near real-time process in order to harvest the data with CDP. So that leaves us with the choice of a transaction or a custom event processing adapter to collect data and make it available in near real time using CDP. Whether you choose to start a new CICS transaction or write your own custom event processor, the user data considerations remain the same. The CICS write journal name command will be used to produce your data. And if we write to SMF, we see the considerations listed on the left-hand side of the screen. Among the biggest advantages of SMF is that a process is already in place to harvest that SMF record. The record is written in a very efficient fashion. Data is structured within the record, and that structured data makes for very efficient processing on the analytics side. The main advantage of using one of the log forwarder data streams is the quicker upfront implementation. Writing to syslog or joblog can be done without building any custom specifications within CDP, but are far less efficient on the analytics side. Consider writing data out to syslog would require that your query run against all syslog traffic in order for your search to come back. Joblog would be a more efficient target, but then you would need to certainly know which CICS region you're searching against. And also, you still have the consideration that the data is not structured when written out to the joblog or the syslog, but rather comes across as just one big character string. So parsing is going to be involved. There are some considerations related to multi-line messages that may become problematic. Lastly, you could introduce a data set as your target and then read data from a VSAM ESDS or from a USS file, but I would wonder why you would want to introduce another data set when there's so many other targets for this data. Item last on the right-hand side is You could use the API to create your own data stream, but there's been really limited uptake for this user API. And at this point, I would say it represents introducing more user code into your CICS. So that would not be my recommendation. Looking specifically at the artifacts required to implement the user SMF record, you see that we've got a PDS member, WBOU110I, that is defined in our user definition library, where within that library there are two members. One is a input record format and an accompanying output record format, which you see depicted on the screen, that map to the collection and production of every user SMF record. So here you'll see there's a define update statement for SMF 110 subtype 1 KPW. This is a user version of the KPI record that we talked about earlier. And as you look through some of the capabilities within this language, you see highlighted on the bottom the group by feature. That group by feature is what was used to create summary records on an elapsed time where there's an interval that has been specified that the records will be grouped. And at the bottom of the screen, you see the transaction name. This is literally the implementation that is used in the 110 summary records. Once we have a user definition library in place, that user definition library needs to be identified to the configuration GUI. Here we've specified a concatenation which includes CDPZU for user HBO defs, along with the product provided ZLDA and CDP concatenations. Moving to the right, now that the configuration utility is able to read my record formats, I need to define that data stream for use. So I put a name of WB Custom CICS SMF on that record type, and at the bottom you could see our SHBO defs dataset member WBOU110I that we saw in the previous slide. Once that definition has been incorporated into the configuration utility, I can select the data stream from a category, in this case the category Custom Data Streams, with a group of user SMF and a subgroup of CICS, shows my WB Custom CICS SMF user record. With my user record then brought into the policy, I would assign it to a subscriber. And again, within CDP, we have multiple protocols to choose from. You see them listed here, whether they be Splunk via data receiver, Splunk via HTTP event collector, Logstash, Humio, Kafka, or the Enterprise Data Warehouse DB2, which is used strictly for IBM's anomaly analytics. In summary, we've looked at the common data provider, in this case, how it's designed to be a sole source of your Z data, that SMF, syslog, and application log information can be brought in to your analytics tooling using common data provider. Many transport mechanisms are available, and ultimately, as it pertains to our use case, that CICS business events can be harvested by common data provider and made available to an analytics platform. I hope you found this video useful. Thank you for watching.